Holy crap.
All right. It's a good beginning of it. All right. So, we're getting into the bread and butter of statistics. Chapter 6, the normal distribution stuff, and Chapter 7, those together are the heart of statistics. Once we learn those things, it's going to be everywhere throughout the rest of what we do. So it's really important. I don't know how else to say that. So what we've learned so far, so let's do a basic problem. So we have a normal distribution, mean of 410, standard deviation of 32. So of course, draw that real quick. Okay. So what's right in the middle of your picture?
410.
410. It's crazy because the mean cuts it in half. For a normal distribution, it's symmetric. Okay, look at it. Now the question I'm asking is going to be, what's the probability x is greater than 470? So where's that at? Yeah, so somewhere up here. So I know the answer is going to be less than 50%. Right? Kind of depends on how relatively far away 470 is to see how small that tail is going to be. Let me say that again. How small that tail is depends on how relatively far away 470 is. If the standard deviation was 60, it's only one step away. Standard deviation is roughly half that, so it's almost 2 steps away. This should be relatively very small area in this tail. Like my picture doesn't have to be to scale, it just has to have things in the right place. All right. So what do I do to figure out this probability? It's amazing, right? I have this chart with all the answers waiting for me. I just have to make a z-score so I can use it. So the formula you should know by heart by now, this guy. So if I change my data point into a z-score,
It's 1.88.
1.88, is that what you guys get?
875.
Okay, cool. And then to find, so this is 1.88. What's this in z-scores?
0.
0. That's the mean, it's 0 away from itself. So when you look up 1.88, go ahead and look that up. Don't say anything out loud yet. Okay, now tell me, what'd you get? 9699, where is that? The minute you look up something in the chart, you put it below the thing you just looked up, because that's what the chart tells you. So if I put the 0.9699, I know that can't be the answer because I know it's supposed to be a small area. But if everybody just put it up there, 9699, they keep going like, that makes sense. That doesn't make any sense. What is the right answer? 1 minus this. Cool. And I don't know if any of you guys use a shortcut. If you look up negative 1.88, it would give you the answer directly. It's sort of like blinkers. If you don't use blinkers a lot, just never use them. Right? So if you don't really use that shortcut correctly, just never use it. It doesn't really save you that much time. Okay, how are we feeling so far about that? Why did I not have to do anything to this? Why did I just use that directly? Because now we know we sometimes have to do something to it. Why didn't we do anything to this?
Because it's normal distribution.
No.
It's not a sample.
There's no sample. I'm not asking about the sample mean, right? So the two triggers to tell you when to use this formula here is I took a sample and I'm asking about the sample mean. So if I said, now, same distribution, all right, same distribution. We take 49 data points, whatever the hell they are. Now find the probability that x is greater than 470. X bar, just be careful. So if I take a group of 49, and I want to know the probability that the average of that group is more than 470. If I took a group, randomly selected 49 data points from this set, what should its average be close to?
Just the same magnitude.
So if I take a sample from that group of data, random sample, its average should be close to what? I love you guys. What is the average of that data? 410. So if I take a random sample of 49 data points, their average should be close to 410, right? If the average age of people at Grossmont is 26, and I take a random group of 49 people, and their average age is 80, where the shit was I? I must have been somewhere weird. I didn't pick a really good sample. Is it impossible for that? Is it impossible? No. It's not impossible. Is it remarkably unlikely? Yes. Right? It's sort of like if they find your DNA in the blood at the scene. Does that mean you were definitely there? No. No. There's a 0.000000027% chance you weren't the one. It's like, holy shit, you were the one then. Shit. Okay, maybe. Okay, maybe. So how do I do this? I do the exact same thing I did here, except I change one thing. What changes? Obviously, that. How do I find the new standard deviation? What do I do? So I do this, right? Tell me exactly. What goes up top? 32. What goes on the bottom? Square root of 49. So this standard deviation is the one that works for individuals. If I pick one person or one thing, what's probably that it is more than 470. I can use that. Here I'm talking about a group. I need the spread of the groups from each other. So I have to change the standard deviation so it's the one for a group, not an individual. Maybe. And whatever the hell that is. 4 point... I almost had it. Huh? 4 point who?
571.
571, all right. If only I would have told you earlier that you have to take standard deviation out of 3 places always. I did this. All right, finish that up. It's the same work, you just have a different standard deviation. Not the one for individuals, you have the one for groups. It's the same exact work, just with a different number right there. So dude it. So, I mean, the idea is, this is for individuals. Groups of 49, it should be much harder for them to get very far away from the average. A group of 49 should be really close to the average. Is it crazy unlikely that there's a 7-foot person just walking by randomly? Is that crazy unlikely? Like, holy shit! No, it'd be like, well, it's a 7-foot tall. Is it really unlikely that a group of 30 people whose average height is 7 foot tall goes walking by just randomly? Yes. You go, what is happening over there? Or what just happened over there? They're not wearing any basketball clothes. I don't know what's going on. My favorite basketball players. Spud Webb, it gave me hope. Spud Webb? Anybody? Muggsy Bogues? 5'3", 5'6". Okay. So how do I finish this out? So here, this picture now in blue over there would look more like this. There should be very little out here. Should be really unlikely to get a whole group that has an average way that far away. That's exactly this. The spread gets smaller. So my z-score now, my picture doesn't really have to change for myself. It's 470 minus 410 divided by 4.571 instead of 32. It's going to be something like that, yeah. I like it. Yeah, maybe 13 point. 13.13? Ooh, I like it. Our lucky z-score. Now tell me something. Is that far away? At this point in this class, you should feel completely comfortable saying, holy shit! Right? Especially because I say shit all the time. You should feel comfortable. We're in a safe place for cussing. But really, the reason is 13 standard deviations is just stupid far away. In everyday terms, that is impossible. So where the chart says 0.0001, and actually it would say 0.9999 here, yeah. It's bullshit. That's for 3.5 and around 3.5. We're at freaking 13. It's about 0 freaking percent. It's like 0.000000002. So I don't say 0%. I say approximately 0. If you put 0.0001, I'm not going to take points off. But I really want you to understand how that's way too big of a simplification. If you're around 3.5, but we're at freaking 13. There's going to be nothing out there. Okay, maybe. Maybe. If you don't understand what I mean by approximately 0, just put 0.0001 like the chart would tell you. That's fine, because it tells you that. But it's wrong. What's up? So again, if you look up 13.13 in your chart, can you?
No.
What's it say though? 3.5 and up. And what's it say about it? 0.9999. Which means what's up here?
The opposite.
0.0001. My point is, we left 3.5 behind like crazy.
That said 70%.
Huh?
That said 70%.
Oh, no. Sorry. It's a very emphatic approximately.
Okay.
Yeah. 70% would be like,
I was really confused.
I've given up on statistics. What the shit is this guy talking about? Which is, you guys are like, I'm like that all the time. Yeah. Shit. Okay, so I'm going to give you guys a problem to try just like what we did. Okay. You can group up if you want to with other people. If other people freak you out, you can stay alone. It's fine. Move your chair over a little bit. There's a free table over there if you need to get away from it. More check. Okay. So mean score is 72.97. The standard deviation was 6.597. You pick Pick one test, find the probability that that test is higher than a 90. Pick 12 tests, find the probability that the mean of those is between 70 and 74. Go.
I know my husband.
I'm not sure why 97. Yeah, 97 was a good year. That's why so many 97s. And you're kind of like, yeah, it was booked.